that option like this, and that looks like it's gone. That looks healthy, so I'm gonna let that be. I need to open up QuickTime. I'm good. All right, let's do like this. Let's try this again. Why? Do you need to be restarted? Let's try this one more time. There. See, I don't even know. I just kept trying and it actually worked. Okay. Let's go like this. Okay, let's do like that. And for right now, I'm gonna close this out and reboot this because I know a lot of times it has to be rebooted. Try to night. I was not trying to do that right now. I think this is the right one. See, I wasn't trying to do this right now. It's gonna mess things up. All right, and then just trying to get things loaded. Everything is moving super slow today. Let's do the chat window. More than likely, the final exam will not be on Pearson. Okay. I do have one ready for Pearson, but it seems like the department, I think I forgot that Morehouse likes to do common final exams. I'm just trying to get this to load properly, and we'll probably be ready to go. While I'm giving that a chance to load, I'm going to hop back over here. I need to do like this. Okay, let's go here. Maybe it's the chords. Maybe I just need some new chords. Okay, that's working properly. All right, I'm just logging into Pearson, and we'll be ready to go. That's going to be up here somewhere. Now, I don't know why it's going slow, other than maybe the servers are busy. Okay, let's do it like this. Let's go here. All right, so we're on the third set of 3. Let me see. So we did 1, 1 to 1, 3, and then we did 1, 4, 1, 5, and 1, 6 as best we could last time. So then we can focus on 2, 1, 2, 2, and 2, 3 today. That's about right. That's about the rhythm. All right. So we'll start with section 2.1 today, and just do as many as we can. I think what I might do is wherever I finish with you all, pick up from that spot with my next class, and that way, at least if it's streaming to my YouTube, then you can get a full review. I think I did have at least one student join my 5 p.m. class on Friday, but again, you see how this is what I don't really know why it's going slow because I got the fastest internet today. We're offering. Let's do like this, and then let's hop here because I know I got to make sure that's showing properly. Okay, that looks right. Let me check one other thing, and then let's go here and then back. There we go. Okay, so we're going to start here with Pearson, and I'll periodically I'll be checking the chat. So it's like if you guys have questions, just feel free to type or unmute yourself, and let's just kind of make our way through as many questions as we can. Identify the graph of the following quadratic. So notice the highest degree is 2, so it's a parabola. Multiplying the outside by a number between 0 and 1 causes a vertical shrink or compression, so it's going to be smushed or wider, and it's going to be flipped upside down. So it has to be either A or B, and we didn't move it up or down or anything like that, so it's just going to be B. Okay. And now if you weren't sure, you can always like choose values of X and find the corresponding Y. You could plug in points. I don't know if the laptop needs to go through an update. I think I have been avoiding an update. Sometimes those like really they'll crash your system, but at the rate at which it's moving, we might need to do it anyway. Okay, again, we got another parabola. Usually I do my transformations working our way from the inside to the out, right? So if I'm rattling off these transformations and anything is not clear, or if you're feeling uneasy, you definitely want to go back and look over transformations, right? So what this is saying is we're starting with the parabola. This says move it left by 3, stretch vertically by a factor of 5, and then flip it upside down. So there should be a narrow parabola that's upside down and it's left 3. I think the only one that does that is A. A is the only one that has those features going on. And again, if you're not aware of those transformations, you can always choose values of X, find the corresponding Y. All right, you could always just choose several points, plot the points, and then line up the graphs, and just confirm several points. I'm trying to think of how I could get this to go a little faster, and that doesn't even look like it's charging. And it should be charging, and if it's not charging, that's going to be trouble. Okay, yeah. Is it on the next one? Okay. Oh, technology. Yeah, I think I might need some new chords. I know that's one source where it causes stuff like this. Okay, so again, transformations. If we work our way from the inside to the out, we start with a U-shaped graph. It says to go right 6 and down by 2. So it's just a regular parabola. We just went right 6 and down by 2. It looks like this one. It can't be C because that's opening the wrong way. That one didn't go right, and this one didn't go down. So on one should be B. Oops. What? Next question. Let's see. Yeah, we're showing the right thing. All right. Match the function with its corresponding graph. So this says to go left 1, stretch vertically by a factor of 2, and then go down 5. So it has to be either C or D because those are the ones that are opening correctly. And then D is the only one that goes left 1, down 5. Yeah, let's just go D. Okay. Let me check the chat. Okay. Find a quadratic function that passes through this point. Okay, this is the form. So what we could do, basically we need to solve for A. We can plug in this X and this Y. So when X is 2, Y is 12. 12 divided by 4 is 3. So then it's just going to be Y equals 3X squared. 3X squared. And you can check, if you plug in 2, the answer should be 12. Okay. This vertex is passed at this point right in its standard form. Okay, we're going to need to take some notes here. Okay. Let me go paper. So this is coming from section 2.1. This is 2.1 quadratic functions. Quadratic functions. Okay. And this is question number 6. No, I'm good. You can have that stuff. This comes from section 2.1, number 13. It says a quadratic function is standard form. So the standard form of a quadratic is going to be y equals a times x minus h squared plus k. All right. It says the vertex. So that means our h comma k. Our h comma k is going to be 0, 0. And passes through the point. So the x comma y is going to be 2, negative 16. Okay. All right, so let's hop over here and see the notes that I'm taking. Okay. So then it looks like we have all the components except for a, so we can plug in everything and solve for a. So then we're going to have negative 16 equals a times 2 minus 0 squared, and the k is 0, right? So then that's going to be 4a. So then a is going to be negative 4. So then our quadratic should be y equals negative 4x squared. I think that's it. Because if we plug in 0, we get 0. When x is 2, 4 times negative 4 is negative 16. So we're going to go y equals negative 4x squared. Negative 4x squared. The vertex passes through that point. So this is similar, just with a different set of points. So we're going to do the same thing. This is number 7. This comes from section 2.1, number 17. Again, the standard form of a quadratic, y equals a times x minus h squared plus k. Yeah, I don't want to install anything right now. It says the vertex, so that means our h comma k is going to be 3 comma 1, and our x comma y is going to be 2 comma 5. Okay. So then let's see if this works. So we're going like this. Does it change? It did change. Okay. So then if we plug in this information, we get what? 5 equals a times x, which is 2, h, which is 3 squared, and the k is 1. So then if we solve for a, we're going to get 5 equals, what is that, a negative 1? So that's going to be a plus 1. So then a equals 4. So then the equation is going to be 4 times x minus 3 squared plus 1. That's it. Okay, let's hop over here. Let me make sure it shows. Looks good. Okay. So the function for parentheses x minus 3 squared plus 1. Next question. Same thing, right? So this is the same thing, just presented differently. So these last 3 examples have all been the same question. All right. Number 8, this comes from section 2.1, number 23. Let's see, general form of a quadratic, f of x equals a times x minus h squared plus k. Let's see, the vertex, so our h comma k is 3 comma 0, and then our x comma y is 4, 1. Okay. I'm gonna hop here. Let's make sure it's switched properly. Okay. All right. So same kind of deal, right? Let's see. So the y value is 1 equals, we don't know a, x is 4, h is 3 squared, and the k is 0. All right. So then it looks like a equals 1. Okay. So then that means the function is going to be f of x equals, what is our h? H is 3. So it's going to be x minus 3 squared. I think that's it. Right here. So if we plug in 3, we get 0. If we plug in 4, we get 1. So x minus 3 squared. We're going to hop back over here. This stuff is being so temperamental. All right, let's see, make sure that's showing properly. And the function, let's see the time. Okay, x minus 3 squared. Okay, going on to the next one. Quadratic function whose graph is given on the right. Okay, same kind of deal. So number 9, 2, 1, 25. Let's see. F of x equals a times x minus h squared plus k. We're given h comma k. Okay, that's fine. H comma k is 4 comma negative 3. And then the x comma y is, let's do 5 negative 2. We can choose either point. Okay. So then we're going to hop over here and switch that as well. Let me make sure it's switched. Okay. So this is where I could use a second screen. Anyway, doesn't matter. Okay, so when y is what? Negative 2. When y is negative 2, we don't know a. X is 5, h is 4 squared, and k is negative 3. So then we get negative 2 equals a minus 3. So then a equals 1. So then we get f of x equals x minus 4 squared minus 3. Okay? So when x is 4, wait a minute, I think we made a mistake somewhere. That's a 1, and that's a 1. X minus 4. Oh, okay, yeah, no, I think we're okay. When x is 4, 4 minus 4 is 0, minus 3 is negative 3. When x is 5, that's 1 minus 3 is negative 2. Yeah, these check out. Okay. I just was stopping too early in my calculation. I was like, why isn't it coming out to the right number? Okay, so let's use this. Let's hop back over here. Make sure it's switched. Okay. So then we're going to say this is going to be x minus 4. So we're going to do parentheses. Try that again. X minus 4 squared minus 3. Okay. Let's see the time. Okay. Rewrite it in standard form. The graph the given function. Okay, let's just write this in standard form. So it looks like I would do completeness squared here. Let me see. So this is what, question number 10. Question 10, this comes from 2-1-27. Standard form. Okay. see, let's hop here like this. Make sure that's switched over. Okay. Oh shoot, I didn't write that. We got this y equals x squared plus 4x. All right. We're gonna write it in standard form. Okay. So completeness square, the leading coefficient is already a 1. So we're going to add 0. We're going to say b over 2. So we're going to say plus b over 2 squared and minus b over 2 squared, right? So right here, we're going to say plus b over 2 squared, and we're going to say minus b over 2 squared. So we're adding 0 in this form. So the blue part that we see is the completeness square step, and that allows us to factor the first part, right? So our b in this case is 4, so we're going to say plus 4 over 2 squared and minus 4 over 2 squared, right? So then what we get, x squared, 4x, that's a 2, so that's plus 4, so we're basically saying plus 4 minus 4, right? If we focus on the first three are going to factor, it's going to be x plus 2 squared minus 4, right? So now this tells us the vertex, we went what, left 2 and down by 4. So let's use this. Let's hop back over here, make sure it's showing. Okay. So in standard form, it should be y equals x plus 2 squared minus 4. To graph the function, so the transformations, we should go what, left 2 and down by 4. Shift the graph of that. We said 2 units to the left and 4 units down. So it's a parabola. So we said what, 2 units left. So negative 2, negative 4, right there. Oh, okay. So 2 units, no, not a stretch. 2 units to the left, 1, 2, oh, that's not 2. And 4 units down. Reflect, no reflecting, I'm gonna hit save. That looks correct, I'm gonna hit check. Okay. The vertex we said was negative 2, negative 4. Negative 2, negative 4. Okay. Axis of symmetry is x equals negative 2. Okay. It looks like I'm eyeballing this, so it looks like it's negative 4 and 0. Negative 4, comma 0. The y-intercept is the origin, so 0. That's it. Okay, graph this function by writing it in standard form. Okay, so another completeness square. It's essentially the same question, but this one is definitely a little bit more challenging because the leading coefficient is not 1. So that kind of will change things a bit. We're going to give it a go, though. So this is number 11. Comes to section 2.1.33. This is going to be y equals negative 2x squared plus 20x minus 25, right? So, Let me hop over here and let me see if I'm showing it. Let me see, what is it asking us to do? Just write it in standard form. Okay. Make sure this is showing. Okay. So now, at first I wanted to see, okay, can we divide everything by 2? But then 25 stops us from dividing everything by 2. So I think what we're going to do is factor out the 2 from the first 2 terms, right? We're going to do it like this. So this is going to be the same as y equals -2, and then that's going to leave us with x squared minus 10x. We're going to leave some space, and then minus 25 is on the outside. So now in this form, we're ready to do our plus or minus b over 2 squared, right? So we're going to still do our plus b over 2 squared and minus our b over 2 squared. Okay? So -10 divided by 2 is -5, so that's going to be plus 25 and minus 25, right? So essentially what we have to do, like we have to distribute this 2. The first 3 items are going to be, the 2 stays in front of those, and we also have to multiply the 2 by that -25. Okay, so then when we do this, we'll get the following. We'll get -2. Now if we can factor those first 3 terms, they factor into x minus 5 squared. And then the -25 times -2 is what? Plus 50 minus 25, right? And I think this will, we got one more step. Y equals this minus 5 squared plus 25. And I think that's it. I think this is okay. I'm trying to think of how we could check it. We could graph both of them on the same axis and make sure it's the same graph. Something has to be off, though. Let me look at them one more time. It's going to be a positive 50, positive 25. It's the fact that the y-intercepts are kind of making me a little bit nervous. Like the first one, let's just go with it and see what happens, and then if it's wrong, we'll come back and find the error. Okay, so let's hop back over here. Go like this. Okay. So now let's see what happens. Standard form. We got this -2 parentheses x minus 5 squared plus 25. Okay, well, that's it. Second time. Okay, let's go to the next one. Oh, so then if we use our standard form, it says to do what? Go right 5, stretch vertically by 2, flip it upside down, and go up 25. It looks like B, right? Where we go right 5, stretch vertically by 2, flip it upside down, and go up 25. Let's just do this one. The vertex is at 5, 25. The axis of symmetry is x equals 5. Y-intercepts. So now let me see if I can look at the graph. I don't think it's apparent from the graph, so we might have to go back. So for the x-intercept, what we have to do is set y equal to 0 and solve. So I'm going to hop over here and make sure it's showing. So I'm going to set y equal to 0 and solve. So this is for the x-intercepts. We're going to have this -2 times x minus 5 squared plus 25. We're going to set that equal to 0. So we can subtract 25 on both sides, and we'll get -2 x minus 5 squared equals -25. Divide both sides by -2. X minus 5 squared. 25 over 2. Take the square root on both sides. X-intercept, we got to do plus or minus, so it's going to be x minus 5. That's going to be plus or minus 5 root 2 over 2. I just went on to rationalize. It's really 5 over the square root of 2. If you rationalize, you'll get this. And then add 5. So x equals 5 plus or minus 5 over 2 root 2. Okay. Okay. Let's go with this for the x-intercepts. So find the x-intercepts, type in exact answers using radicals as needed. Okay. Let's see. Comma to separate answers. So I'm going to say 5 minus 5 over 2 times the square root of 2. I'm going to hit comma, and I just want to copy all of that. Can I just copy? Copy, paste, and change that minus to a plus. Okay. See the time. Okay, that's essentially time for us. Let me check the chat really quickly. Let me see. Y-intercept. So if we set x to 0, y is negative 25. Okay, so, you know, just know that what you're experiencing is, I don't know if it's going to give you any solace or not, or it's going to make you feel any better, but most college algebra, like all college algebra students I've ever come across, no matter what institution, I mean, I've been teaching at this level for like 10 years, from when I was in grad school to Morehouse to several other institutions, students always have a hard time. Like, they just, you know, you just have to do your best. You know, you just have to do the best you can, okay? But you're not alone in the struggle. Like, there are so many people across the country, across the world that go through the same kind of thing. Click that. But yeah, just do the best you can, and everything will be okay. You have to know that. No matter what happens, ultimately everything's going to be fine. Okay, guys? You're welcome to join. I'll be back on at 5 o'clock with my next class. You're welcome to join. Just use the same link if you wanted to just see more examples. Otherwise, enjoy the rest of your day. And tomorrow's our last day. And again, as far as the final is concerned, I'll be in contact via email as far as details on that. It's looking like our final is going to be that Wednesday during final exam week. And it's going to be some kind of common final. I don't know all the details yet, so I'll have to get back to you. Okay, guys. Enjoy the rest of your day. I'll see you next time.